on numerical problems which are NEET based questions on these two articles, that is power and LCR circuit, and another article is just now we have taken coil rotating in a uniform magnetic field of induction. So the first problem is here. Average power dissipated in AC circuit is 2 watt. Average power dissipated in AC circuit is 2 watt. If current flowing through a circuit is 2 ampere, if current flowing through the circuit is 2 ampere and impedance is 1 ohm and impedance is 1 ohm, what is the power factor of AC? Then what is the power factor in AC? This is the question. Some options are given here. Directly let us go to the answer, the solution using power equation. Solution: P is equal to E into I into cos phi, that we have learned just now. So that is equal to I square into 2 cos phi, because it is also E is equal to IR. So that is I square into 2 cos phi. So we get cos phi is equal to, so we get cos phi is equal to P upon I square into 2. So that is equal to 2 upon 4 into 1, 2 ampere. The 2 watt is the power, 2 watt, 4 into 1. So that is 2 upon 4, that is 1 by 2, that is nothing but 0.5. What is this? This is the power factor. It has no unit. So another thing is, the second problem we are going to take here. The next problem is like this. So same NEET question we are following. In LCR circuit, series circuit, an alternating EMF and current are given by. So the next problem is, in LCR circuit, the alternate EMF and current I are given by. Alternating EMF and current are given by equation E is equal to, by E is equal to, that is 100 sine 100 t, 100 sine 100 t odd, and I is equal to, and I is equal to 100 sine 100 t plus pi by 3, 100 sine into 100 t plus pi by 3 milliampere. So the current and voltage are given to us. The question is, what will be the power factor? So the power factor we are interested here. So comparing these equations with the actual equation E is equal to E0 sin omega t and I is equal to I0 sin omega t, we will get here power factor is equal to power factor by comparing these two equations with the standard equation. What is the standard equation? E is equal to E0 sin omega t. And what is the standard expression for current? I is equal to I0 sin omega t. Comparing these two equations with these two standard equations, we get power is equal to E0 by root 2 into I0 by root 2 into cos phi. This is power factor. So here 100 and 100 are given to us. 100 and this is also 100. Whereas upon root 2 into root 2 is 2. So 200 upon, 1 into 1. 10,000 divided by 2 into 1 by 2 into 10 raised to minus 3. That is into, that is 2.58. So after simplification, we are getting this particular answer. So this is about how to calculate the power factor in LCR circuit. So rest of the problems are going to be continued. The next problem about the alternating currents is the fourth one is like this. EMF is given by E is equal to 20 sin 50t. EMF is given by E is equal to E0 sin 50 into t. This is given 200 sin 50t. The RMS value of current in a circuit, this value is given as 200, comma, the RMS root mean square value of current in a circuit of resistance 50 ohm, of current in a circuit of resistance 50 ohm is how much? Very clear cut question. Electromotive force is given by E is equal to 200 sin 50t. The root mean square value of current in a circuit of resistance 50 ohm is how much? Options are given here: A, B, C and D. See, the options are 0.28, 0.02828, 0.02828, B is 0.2828, the third is 2.828, and the fourth one is 28.28. So, what is the value of current? Root mean square value of current in a circuit of resistance 50 ohm. So, solution to this problem is like this. E is equal to 200 sin 50t. Comparing this equation with the standard equation, we get E RMS is equal to 200 by root 2. Solution. Comparing this equation with standard equation, we get here E RMS is equal to 200 by root 2. Volt. And now IRMS is equal to ARMS by R. And now root mean square square value of current IRMS is equal to ERMS by R, ERMS by R, which is given by 2 into root 2. Means let us put the values 200 upon root 2 into 50. 200 upon root 2 into 50, that is 100 divided by under root 100 means 10, that is root 2 root 2, and the value of root 2 you might be knowing, so that the answer C is correct, 2.828. This is nothing but the root mean square value of the current. So the next problem comes to you is like this. The fifth problem to this is like this. A multimeter reads a voltage of certain AC. A multimeter reads certain voltage of AC, alternating currents. Means alternating voltage you can say, of that AC source as 100 volt. AC source is 100 volt. What is the peak value of voltage of AC source? What is the peak value of voltage of that AC source? So the question is clear cut here, that there is a multimeter and it has a certain AC value, certain value of AC source 100 volt. What is the peak value of that voltage, maximum value of that voltage? That can be derived by this method, that V0 is equal to root 2 into VRMS. Solution is, we are interested to calculate V0, that V0 is equal to root 2 into V root mean square value of current, RMS, value of that voltage. That is V0 is equal to root 2 into, what is that VRMS value? It is 1.414 into 100. Means the value of this is 1.414 into value of this is 100. So in this way, the peak value of the voltage is 141.4. 141.4 volt. So this is the correct answer. This he was asking you, what is the peak value of voltage? This V0 is the peak value of voltage. It is 141.4 volt. And now the last question is like this. An AC voltmeter is connected to a source of an AC voltmeter instead of multimeter. You can see here an AC voltmeter is connected to a source of E0 is equal to is connected with a source of E0 is equal to some volt, then it will be read read how much? What it will read is the question. And the options are here. That 10 volt, so 10 Newton, B 100 volt, 1000 volt, 1 volt. It should be 10 volt. 10 volt, 100 volt, 1000 volt, and 1 volt. What should be the correct answer to this question? So here, let us say the calculation of this is ERMS we have to calculate, and the formula for ERMS is E0 by root 2. Means already the value is E0 value is here peak value, which is 141.4 that we have calculated just now. So let us put the expression ERMS upon root 2. And the solution to this problem is like this. If we are interested to find the value of that voltmeter, then it can be denoted like E0 by root 2. So E0 is 141.4 and value of root 2 is 1.414. So the simplification of this is 100 volt. In this way, the voltmeter will read 100 volt. So option B is correct. So that's all about the practice of numerical problems on based on this electromagnetic induction, but in that coil rotating in a uniform magnetic field of induction and powering LCR circuit. Thank you very much.